Hi all. Today we'll be discussing the LeetCode problem of the day, minimum deletions to make string balanced. So here you are given a string which consists of only characters A and B. So you have to delete, you can delete any number of characters to make the string balanced. So a string is balanced if there are no pair of indices I and j such that I is less than j and s of I is a character B and s of j is a character A. You just have to return the minimum number of deletions to make the S balanced. So basically in your end, in the end of the string, you should not have any occurrences of B appearing before A. So either you can have something like all A's first and then maybe some B's. So this is valid because B is not appearing before A. Or you can have only A. So this is also a valid end string. Or either you can have all B's. So this is also valid. But you can't have a string like this. So B, 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 and then A, A. So here a B is appearing before A. So this string is invalid and this is not balanced. Only these type of strings are balanced. And you have to return the minimum deletions needed to make it balanced. So let's look at the examples. So first example, you have A, B, A, then B, B, A, A. So one thing we need to do is first we should have all A's, then we can have all B's, or only A's or only B's. So in this string, if you want only A's, that means you have to delete all the B's. So you have total 3 B here. So it will take 3 operations to make it all A's. So this will give you 3 operations. If you want to make it all B's, then you have to delete all the A's. So 1, 2, 3, 4, 5. You have total 5 A's here. So number of operations to make the string all B is 5. And if you want to have it like mixture of A and B, so starting can be some A's and ending can be B's. So for this also you will have multiple ways you can do it. Suppose only till here I want A and then rest of the string all B. So in that case, you need to delete these 4 A's and it will cost you 4 operations. So the optimal way to do it is A, A. You can either start at index 0. Oh, I think I've written the string wrong. So this is B here. So to make the string all A's, you will take 4 operations because there are 4 A's here. And to make the string all B's, you will take again 4 operations because you have 4 A's. Now, to have a sweet spot between A's and B's, if you will take all the A's till here, if you want all the strings from this index to this index to be A, and let's say the rest of the string should be B. So for that to happen, you need to delete this B, so that you'll have A. And in this part, you need to delete this A. So total, we have made 2 deletions, and this is the least we can achieve. So the output will be 2. So once we have deleted this, the string will be A, B, B, B. Now let's look at the second example. Here we have B, B, A, A, A. Okay, 5 A's, and then again BB. So like we discussed, we can make the string of type AB or A or B. So if you wanted to have all A's, you need to delete 4 B's. So 4 operations here. And if you want the string to be all B's, then you need to delete 5 A's. And if you want to have a mix of A and B, let's say till this part, we should have all A's, and till this part, we have to have all B's. So this is already satisfying. We have all B's here. And here, to have all A's, you need to delete these 2 B's at the starting. So once you delete them, your string will be 5 A's and then 2 B. So total number of operations you did is 2, and this is the least possible. So now coming to the constraints, the string length will be from 1 to 10 power 5, and string will contain only A or B. Now let's go over the approach. So like we discussed, the final balanced string will be of the following 3 types. So first, it will be all A's followed by some number of B's, or it can have the string should be contain only all A, or the string should contain all B's. So these 3 type of strings are balanced string, and rest of all are not balanced. So let's see how we can solve it now. So if we look at this case, if you want the string to be all A's, then you just need to delete all the B in the string. So in this case, we have total 4 B's. Total number of deletions will be 4 to make the string all A. Similarly, if you want the string to be all B's, then you have to delete all the A present in the string. In this example, we have 4 A's. So the number of deletions will be again 4. So these 2 cases are now clear. We just need to look at this case where some number of characters at the starting will be A and the rest of the characters will be B. So here as well, we can have multiple possible ways. That means suppose this part of the array should be, this part of the string should be all A's, and then rest of the string should be all B's. So this is one of the case. And we can have another case like this part of the string should be all A's, and this part of the string should be all B's, and so on. So we can have multiple possible configurations. So out of all the possible configurations, we just need to return the which possible configuration is giving us the least answer. So let's take a random configuration. Let's say I want this part of the string should be A, all A's, and the rest of the string should be all B's. Now to achieve this part, if I want this part of the string should be all A, in that case, I have to delete all the B characters in this part of the string. So here the count of B is 1. So I need one operation to make this part of the string all A. Now coming to the second part of the string, since I want all B's, I have to delete all the A's present in this part. And since we have 2 A's, I have to do 2 deletions. Overall, in total, 3 operations are required such that this part of the string will be all A and this part of the string will be all B's. So if we split it at this point, we'll get the minimum answer as 3. Now let's say if we split it at some other point, then we might find a better answer. So let's say if we are doing a split here, so this part should be all A's and this part should be all B. So here number of B characters is 1, and in this part number of A character is 1. So if we add them, you get the total answer as 2. And this is actually the optimal answer for our example. That means you just need to do 2 deletions such that the resultant string is of this type, starting some A's and ending all B's. So now let's see how we can simulate and find the answer for all possible configurations. So first of all, let me take 2 variables. First will be count of A. Count of A initially denotes count of all the A characters from index 0 to index 7. So I'll also write the indexes. So from index 0 to index 7, how many A's are present? So in this example, we have 4 A's. And let's take another variable, count of B, which is initially empty. And since it's on an empty string, let's say count of B is 0. So now if you add count of A and count of B, you will get the value as 4. And this denotes, since you're counting number of A's, this 4 will denote this case. That means the entire string, the entire resultant string will be of only B's. So to make that happen, we need to delete all the A from the string. And we have 4 A's in the string, which is denoted by count of A. So if we delete all these 4 A's, you'll get the entire string as B, which covered this case where the entire string should be B. So right from the beginning, the first case is covered. Now we'll extend this to find out all the remaining cases. So let's see how we can do that. Initially, I'll start iterating from index 0 to index 7. Initially, let's say I equal to 0. So I equal to 0 denote I want starting from index 0 until index 0 to be all A's, and from index I until the end of the array I want to have all B's. So now this count of A denotes the number of count of A's from index 0 to index 7. But in this configuration, we want to find the count of A from index 1 to index 7. So we have 0 to 7, but we only want 1 to 7. That means we have to subtract the contribution of the index 0. And since index 0 is an A, and A is contributing to this count, and this index is now removed, the count of A will reduce by 1. So count of A will be 3. And this 3 is denoting the count of A's from index 1 to index 7. Similarly, we need to add the count of B. Since 0 is a new index introduced, and since the value is A, we won't add anything to the B. That means this 0 is indicating how many B's we have from index 0 to index 0. So I hope till here it's clear. Count of A denotes how many A's are present in this part, and count of B denotes how many B's are present in this part. Like we can see, count of B is 0 because we don't have any B's here, and count of A is 3 because we have 3 A's. So when we add count of A and count of B, we get a value as 3. So if we do 3 deletions, then the string will be balanced. That means this part of the string will be only A, and the rest of the string will be all B's. So now this one, we'll just keep moving forward. So this is where we do the split. Now I will increase. So when I increase, that means we are moving the split. So instead of the split happening at 0, now the split will happen at index I. So split is happening at index I. That means we have to again update both our variables. So count of A initially was storing count from index 1 to 7, but now we only want count of A from index 2 to index 7. So we have to subtract the contribution of index 1. And since index 1 is an A, we will reduce the count of A. And since index 1 is a B, we won't increase anything to the count. And count of B currently denotes count of B from index 0 to index 1. So let me just write how we update the count of A and count of B. So when we iterate on I, if S dot caret I is an A, then we'll do count of A plus minus minus, because A is reduced, A is decreased from this range. Else if S dot caret I equal to a B. If it's a B, then we will increase the count of B, because I is being introduced and we need to add the count of B. So this is what we do to update our values. So far we have not encountered any B, so that's why count of B remains 0 only. So in this configuration, we have count of A is 2, count of B is 0, 2 plus 0 is 2. So this is some other more least answer we found. So for now, we'll set answer as 2. That means in the starting, we don't need to delete anything because count of B is 0. But in this part, we need to delete 2 A's such that all this will become B. So this is what is our answer. Now let's move I forward. Yeah. So now the split will happen here. Now again, count of A is denoting from, sorry, I didn't update this before. it was 2, 7. Yeah, so now count of A was denoting count of A from index 2 to index 7. But now we only want from index 3 to index 7. So we have to subtract the contribution of index 2. But since index 2 is a B, so count of A remains same. So no update for count of A. But for count of B, we can see that index 2 is a B. That means count of B will increase by 1. So count of B is 1. So if we quickly validate it, now count of A is representing A count from 3 to 7. And count of B is representing B count from index 0 to 2. So from index 0 to 2, we can see B count is 1. And from index 3 to 7, we can see A count is 2. So total number of deletions is 2 plus 1, which is again 3. And 3 is not less than 2, so we won't update the answer. So similarly, we'll quickly complete the simulation for the rest of the indexes. Now let's say I is here, so the split will happen here. And since I is A, count of A will decrease by 1 and count of B remains same. And count of A denotes A count from index 4 to 7 and count of B is from index 0 to index 3. So again 1 plus 1 is 2. So the answer is still 2 and you didn't find any better answer, so you won't update anything. After this, I will increase forward. I will move here. The split will be happen here. So the current character is B, so count of A remains same, but count of B will increase by 1. So count of B is 2. And count of B is indicating count from index 0 to index 4. And this will be from index 5 to index 7. So from 5 to 7, we have count of A is 1, which is true. And from index 0 to 4, we have count of B is 2, which is also true. So total count will be 1 plus 2, which is 3. Again, 3 is not less than 2, so we won't update our answer. Next, we'll move our I further. I will reach here. And this is where you do the split. And since current as character of I is a B, so count of A remains same, but count of B will increase by 1. It becomes 3. And this will be from 0 to 5. And count of A will denote from 6 to 7. And the count will be 1 plus 3, which is 4. Next, I will again move forward. So I is here. This is where you do the split. So since count of I, character of I is an A, so count of A will reduce by 1. And count of A is denoting A count from index 7 to 7. So we can see from index 7 to 7, we have 0 A's. And B remains same because current character is A. And this we can update from 0 to 6. So the answer will be 0 plus 3, which is again 3. Now finally, let's move I again. So now I reaches 7. So this is the important part. If I is at 7, that means from index 0 to index 7, we should have all A's. So that means this part will be all A's. And the rest of the string, which is nothing, will be all B's. And again, the current character is B, so we'll increase the count of B by 1, so which is 4. And this will be from 0 to 7, and this will be nothing. So count of A is 0, count of B is 4. So we can see count of B is 4. So if we remove all B's from here, we'll get the answer. We'll get the remaining string which contains all A's. So this will cover the all A case. So all B case is covered at the starting. All A case is also covered at the ending. And this hybrid case is covered in the between index. So once you do all the iterations, whatever is the least answer you got, you just return it. Now let's quickly code the approach so that it will be a bit more clear. So first let's take s.len and let's take two variables, count A and count B. Initially both are 0. So first, like we discussed, we need to iterate on the entire string to find the count of A. So int I equal to 0, I less than n plus plus if s dot parrot I is an a, then count a plus plus. So once we have the count a, our answer will be initially count a. That means we have to delete all the a's in the string. Now let's start doing the hybrid case. So let's start iterating on where we have to split. So I equal to 0, I less than I plus plus. So first we need to check, again the same thing. The current character is a, then we need to remove 1 from the count of a, because count of a initially holds the count and we are doing a split, so this contribution must be removed. And similarly we can write else if current character is a b, that means a new character b is introduced, so we have to increase the count of b. So let's say count of b plus plus. So this is the updated count a and count b for the configuration where a will be from index 0 to index I, and index I to the end of the string should be all b's. And to get the contribution, we just need to add count a and count b. And let's store it in answer. So answer equal to math.min answer comma count a plus count b. And finally, at the end, you can just return answer. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity first, we are iterating on the entire string once to have the count of a, and then again we are iterating on the entire string to have the partition. So this is order of n and this is order of n. So overall time complexity will be order of n. And coming to the space complexity, it will be constant because we are not creating any prefix arrays or anything. We are just initializing few variables like the count, array size, and the iterator. So space will be constant, order of 1. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.